this is the video for trinomial factoring for Math 95. And so in the same way that the greatest common factor undoes distributing, right? We talked about that in the last video. Trinomial factoring undoes distributing when you have two binomials, just like I've set up here. So I've got them set up with the same 3 and 5 in the parentheses, but with the signs changed in each case. So let's multiply this through. We get x squared plus 5x plus 3x plus 15. And so this is x squared plus 8x plus 15. Down here, x squared minus 5x minus 3x plus 15. So this is x squared minus 8x plus 15. Over here, x squared minus 5x plus 3x minus 15. So that becomes x squared minus 2x minus 15. And down here, x squared plus 5x minus 3x minus 15. So x squared plus 2x minus 15. So the reason why I'm going through this is because these are the things that I'm going to talk about as we're doing the factoring problems, right? I recommend that you begin each of these factoring problems by looking at the constant term, whatever that may be, and the sign that's in front of the constant term. I think that's a good place to start, okay? These numbers that you fit in here will always multiply to give you the constant term. Notice in each case, the 3 times the 5 gives you the 15. But if it's positive 3 and positive 5, or negative 3 and negative 5, in both of those cases, you get a positive 15. Over here, positive 3 and negative 5, or negative 3 and positive 5, you get a negative 15. Okay? And the key there is that if you're looking to factor this, okay, this says that you're looking for two numbers that multiply to give you 15 and then will add up to give you 8. Okay? And whether it's a positive 8 or negative 8 is going to be determined by whether this is plus plus or minus minus. Okay? Same thing down here. We want these to add up to give us 8. All right? Over here, where the signs are different, they're counteracting each other, and so we want a difference of 2. Okay? Same thing here, a difference of 2. The only difference is this sign is going to tell you that this 5 should be negative and that 3 should be positive, and vice versa here. This is telling us the 5 should be positive and the 3 should be negative. Okay? So that's the basis for this idea of trinomial factoring. Let's look at a couple examples here. And then we'll move on and look at the more challenging version of trinomial factoring. But first, let's get set up with the basic ideas. All right. Let's see here. So let's start out with number 6 on this first handout. We've got m squared plus 2m minus 35. Okay. So a minute ago I was saying that it's a good idea to start this problem by looking at the 35 because we want factors of 35, numbers that multiply to give us 35, and that's pretty much it. 1 times 35 or 5 times 7. And we want the factor pair that has a difference of 2. Well, this one's pretty straightforward. 5 and 7 have a difference of 2, so this will factor with the m and the m and the 5 and the 7. Now, it doesn't matter where you put the 5 and the 7. I could have set it up like this. But now, we need to put the signs in, okay? And so now it will be important which number gets which sign. This is saying that we want a positive 2 out of this. That means the 7 should be positive and the 5 should be negative. It doesn't matter how you arrange the parentheses. What's important is that you have the correct sign in front of the correct numbers. Okay, That's problem 6. Let's see here, problem 8. Excuse me. X squared minus 17x plus 72. Okay, so in this one, 72 has a lot of factors. It's one of those numbers that is divisible by a lot of other numbers. And we can list all of these factor pairs out, and in fact, I think I'll do it in a minute. But I can tell you, in the end, it's most common for the smallest factor pair to be involved in these problems. Otherwise, those middle numbers tend to get very large. And just, in terms of probability and statistics, statistically, the smaller factor pairs tend to appear in these problems. So why am I talking about this? So let's look at these factor pairs. 1 times 72, 2 times 36, 3 times 24, 4 times 18. Let's see. 5 does not go into 72. We do have 6 times 12 and 8 times 9. And you can build this list yourself just by dividing 72 by 1, 2, 3, 4. The 5 won't give you a whole number, so you skip it. 6, 7 doesn't give you a whole number. And once you get here, you can stop, because the next pair we already have. Okay? All right. So what I'm saying is that it's more likely for your answers to come from the factor pairs that are closer together than the factor pairs that are farther apart. Not to say that these won't ever be the answer, it's just more likely here. So I usually start my guessing with these factor pairs. And you can see right away, actually, that these do add up to give us 17. 8 plus 9 gives us that 17 that we want. And so we can go ahead and put this in here. And you can do this without listing out the factor pairs. Like if you know that 72 is 8 times 9, and you can see that 8 and 9 make 17, well then you're done. And you don't have to bother with this. Okay? Alright, let's look at a couple more. And then we'll move on to the trickier ones. Let's see here. Well, let's look at 16. 16 is kind of interesting because it's also a problem with 72 in it. And so I'll just leave all those factor pairs up there. Let's see here. 16, w squared minus 15w minus 72. So now we want a factor pair that has a difference of 15. So let's see, do we have that here? This is a difference of 6. This is a difference of 14. This is a difference of 21. This one looks like it's going to be prime. And that happens from time to time. Although I can tell you I just made an answer key for all the odd problems, and they're all factorable. Okay? This one is actually not factorable. And sometimes people ask me, how can I tell whether or not something's going to be factorable? And people usually don't like the answer, but I will tell you anyway. The answer to how can you tell if this is factorable is to take the radical part of the quadratic formula, b squared minus 4ac, calculate b squared minus 4ac, which in this case is going to be, let's see here, 225, that's 15 squared, or negative 15 squared, I'll go ahead and put that in there, minus 4 times 1 times negative 72. So what does this come out to be? 225 plus 4 times 72, so that's square root 513. If this is not a whole number, then this thing's not factorable, okay? Because for this to come out from the square root as a whole number means that this will be factorable into whole number factors, okay? If this comes out to some irrational value, that means we're not going to be able to get nice whole numbers into our factoring scenario. All right, let's look at a couple more here. What else do we have? Let's see, problem 20. M squared minus 19m plus 84. Okay. Well, let's do the same thing for 84 that we did for 72 here. 84 is not quite as easy to factor, but we know 1 times 84, 2 times 42. 3 does divide in there evenly, doesn't it? It's going to be 3 and then times 28. And then 4 times 21. Am I like getting really lucky on picking out the prime polynomials that can't be factored? We need something that's going to add up to 19. Oh, no, I'm not done yet. Let's see. 6. Does 6 go into 84? Yeah, it does. 6 goes in 14 times. Now, those don't add up to 19, but the next set will. This is the one I knew, but I figured that not a lot of other people know that, so I thought that I would list them all out. But notice how, again, it's the factor pair that's closest together. These do add up to 19, so this is going to be m minus 7 and m minus 12. Okay? And you can build this list, like I said, just divide by 1, 2, 3, 4, 5, 6, 7. If it's not a whole number, don't write it down. Okay? And again, once these cross each other, once they get close together, you can just stop because the next pairs will be 12 times 7 and so on. Okay. All right. Well, let's move on and look at the more challenging problems. So the next handout starts with some problems at the top of the page. Let's see here, 9x squared minus 3x minus 2. And I've filled in the first set of parentheses and then left the second one blank. So for these problems, right, just filling in that blank parentheses, all you have to do is figure out, well, I've got a 3 here. What do I have to multiply that by to get the 9? Well, and we're going to need another 3x. And then here I've got a positive 1. I'm going to need a negative 2 so that this multiplication right here gives us negative 2. This multiplication right here gives us the 9x squared. Now the key to these problems, and I'll talk about this more when we get to the problems on the bottom of the page, that number in the middle, okay, is going to come from the 2 multiplications that I didn't mark off yet here. Here and here. Okay? The outers and the inners. If you think of this multiplying as FOIL, okay, these first 2 give you the 9. The last ones give you the 2. You've got to set it up so that the outers and the inners give you that minus 3 in the middle. Okay? And so we can test that out. So there's our 9x squared minus 6x plus 3x and minus 2. And so there's our minus 3x in the middle. Okay? So we'll do more with that, like I said, when we get to the ones on the bottom of the page. For right now, let's go ahead and do number 4. Well, number 4 is a little bit different. We start out with 3k squared minus 9k minus 30. And the idea here is we're going to factor out a 3, because that'll make all these numbers smaller, and that is nice. I mean, I like to have less work rather than more work in most situations. Okay, so now all we have to do is factor this one. And this is really not so bad. Factors of 10, you don't have a lot of choices. 5 and 2 have a difference of 3. And then we want to set it up so we get a negative 3. So we'll make the 5 negative and the 2 positive. Okay, so there's 2 examples for what we're going to be looking at on the assignment. So let's get into that and take a look at it. Okay, let's see here. let's look at problem 8. Problem 8, we've got 5z squared plus 12z plus 4. All right, so one of the keys here is to look at these, the front number and the back number, okay, and determine what are the factors for these. The factors of the 5 are 5 times 1. Factors of the 4, 1 times 4 and 2 times 2. So those are our choices. Those are the factor pairs we're going to be drawing from to try to solve this problem. Okay. Well, we don't have any choice for the 5. So we might as well just go ahead and put the 5z and the 1z in there. Now the idea is we want to set this up with factors of 4 so that this and this add up to give us 12. Okay? Now there are other ways to go about doing this factoring. If you're comfortable with one of those other methods and it works for you, by all means go ahead and use it. Okay? I honestly believe that that's one of the most wonderful things about mathematics is that however you choose to do a problem, as long as it's mathematically valid, that's what you should do. I once had a professor who grew up in the Soviet Union and said that that was his favorite thing about math class, is because he could do something different from what the teacher said, but it would still be right, which didn't happen very often in the Soviet Union. So, all right. So let's get back to this method. The idea here, we can fit the 4 and the 1 in there. I mean, I would put these in first, but I know that those are going to work. So let me just show you how the 1 and the 4 don't work. I put the 1 here, the 4 here. This is 20 plus 1. That's 21. That's not right. We need 12. Okay? So let's swap the 4 and the 1. Now this is 5 and 4 make 9. Still not right. So we've tried them in both cases. They don't work. Okay? The 1 and the 4 don't work. Now let's put the 2's in there. 10 and 2 make 12. We want it to be a positive 12. There we go. Okay. Let's see here. What else? Now let's look at problem 12. This is 20x squared plus 11x minus 3. Okay. So first we want to look at the first coefficient and the last coefficient. This one is 3 times 1. Over here we've got a lot of choices. 20 times 1, 10 times 2, and 4 times 5. Okay, so this time I'm going to put the 3 and the 1 in there because we don't have a choice. Okay, now I want to fit some of these in here so that we get a difference of 11. So remember my advice to start with the factor pairs that are closest together. So let's try the 4x and the 5x. And we want a difference of 11. So this is 4, this is 15. 15 minus 4 is 11. Right? Now, we want a positive 11, which means that the 15 should be positive and the 4 should be negative. So over here, that'll make the 4 negative. Over here, that'll make the 15 positive. Okay? All right, let's see here. What else? What else? Now let's look at problem 16. So 2x squared plus 13x minus 18. Okay, so again, the 2 is 2 times 1. This 18 times 1, 9 times 2, 6 times 3. All right, so let's take this one first and just fit the 2 and the 1 in there. 2x and 1x, because we don't have a choice. It has to be 2 times 1. All right, now we want this multiplication and this multiplication to have a difference of 13. And I'm going to start with these, the 6 and the 3. So let's see what we get here. 6 and 3. 6, 2 times 3 is 6, 1 times 6 is 6. Those have a difference of 0. So that's not going to work. Let's swap the 6 and the 3. That'll be 12 minus 3 is 9. Also not right. Okay, so that one turned out not to be the factor pair that's closest together. That's okay. Let's see here. What else can we do? Put the 9 here and the 4 here. That'll be 8. That'll be 9. 9 minus 8 is 1. If I do that, 18 minus 4 is 14. Okay, also no good. And that's it. The 18 and the 1 aren't going to be very helpful. This is going to be 18 minus 2 is 16. And if I switch them up, that'll be 36 minus 1 is 35. So none of them worked. Okay? And so if we do that little trick I was talking about a minute ago, you don't have to do this, but it is a way to determine whether or not this is actually factorable. We can do b squared minus 4ac. Now, I realize some of you may not have seen the quadratic formula recently or worked with it much. If that's the case, don't worry about it. You don't really need to know this right now. We'll talk about it in a few weeks, okay, in more depth. But in any event, this is going to be 169 plus, let's see, what is that? 8 times 18 is 144. Yeah, and that is not a perfect square. Okay, so this one is not factorable. Turns out to be a prime polynomial. But again, got an answer key for all the odd problems on here. All the odd problems are factorable. So please don't. I hesitate to talk about prime polynomials because often what students do is once they learn about prime polynomials, they look at a problem and they just go, ah, no, it's prime. Without really trying too much. So please don't do that. All right, let's see what else do we have here. Well, let's look at problem 22. This is 4y squared plus 4y minus 3. Let's see what we get. So, look at the first coefficient and the last coefficient. So this is 3 times 1, and this one is 4 times 1, or 2 times 2. So let's put the 3 and the 1 in there. All right, now we need these two multiplications to have a difference of 4. All right, let's put the 2's in there, 2y and 2y, so that's 6. And that's 2. 6 minus 2 is 4. That's what we want. Okay, good news. We want a positive 4. That means the 6 should be positive and the 2 should be negative. Okay, well, that's it for the trinomial factoring. I encourage you to practice with these, to work through them, and the more that you do that, I think the easier this process will get. Okay? There just aren't that many of these problems, and the more that you get done, the more likely you are to see one that you're familiar with. So I encourage you to work through these and then to do the quiz. So, as always, if you have any questions, please let me know. Thanks.